podcast about Grapher and Excel, things like that. So we're actually going to start you with the phase shift. So I've almost got a function here. You can see it right here. And it just needs to be moved over a little bit. Now, one thing I love about communication is when you actually have pieces of communication within the graph. So I'm going to show you how to do that right now. So you're going to go to Object, Insert Rectangle, and maybe just put it up here. And then you can just double click on it and say phase shift.
And phase shift is probably new vocabulary for some of you, and that's simply how much the graph is going to move along the x-axis.
Right. Okay. And then we can go insert arrow, copy paste, get two of them, and whoops, I'm just going to grab one of them if I can. That's hard. I'll grab the end here. No, what's going on here? Grab, there we go. So I'll put this one here. I can say that this is a maximum right about there, and I can put this one, this is hard, right there. Okay, and then that's a maximum right there. So that's how much I have to shift it. I have to shift the function, this maximum, to right there. And you can see that that's about 95. Well, I think we can do a little bit better. So that's about 90. And that's about 100 and, what would you say?
70.
170. So that's
75.
about 80 away, right? So, and you can say maximum of the curve is, what did we say, 95?
Yeah.
Maximum of the points is, what did we say?
170.
170.
5.
Therefore, oh, need a longer box here. For shift, how much? 85?
85.
Okay, so we'll try that.
Where's that 75?
We'll try 85. That's 75, isn't it? Yeah. That's easy math, Miss Barbie. Shouldn't be telling me the things that are wrong. We'll start with 75. Okay. All right, so that's good. That's good communication. I love seeing that. So we're just going to move it 75. We're just going to copy and paste. We'll just new equation. Copy this and paste it right here. And then squeeze right in there with the x, minus 75. That will move it to the right 75. And there you go. Okay, and then you can say maybe it's ended up being closer to 80. You can move it 80 and say shifted it 80 here. And your max, just change it a little bit because it was all estimation. But the estimation is fine as long as you have reason for the estimation. I think that's what we want to see. Right,
good communication with good terminology.
Right. Okay, so that's all good stuff. Now we're going to move on to building a regression model. So I'm just going to turn this one off. I can get rid of this stuff. We're going to build a regression model. So go to untitled data point set right here. Interpolation. We are going to build a custom model. We're going to go A times sine parentheses B parentheses x minus c plus d. Okay, that should be the function that you've been working with. See right here, A, what's under here? A, B, C, and D. Okay, and you're going to push plus right here, put in C. You're going to push plus right here and put in D. Okay, so we have A, B, C, and D. And then you need to have some initial values. I just put 1 for all of these. And push interpolate. It'll give you some values here. Push stroke, and it will put it up in here.
What does that mean, stroke?
Stroke means actually you're going to graph it, basically. Yeah. And push close. So you can see right here, we've got two functions. Unclick that one. That's the best one. and that's yours. They're actually pretty close. So we can go and evaluate these values here, see how close we were. So A was negative, ooh, it wanted to do the negative. That's okay, I guess. There's other ways to do this. B was 12.12. Yeah, that's okay though. The sign goes over and over and over again, so they just decided to take a negative, but that's okay. All right, so now what we want to do is we're going to go to the point set here, edit points, select one of them, and then push Command A to highlight all of them, Command C to copy them, go over to Excel, we'll put in days here, Wolfram data there, we'll put in P1 for our data and P2 for their data, for the computer's data, and just push paste, puts it right in there for us. P1. Now
okay, wait, I have a question. You don't want to use the export button there.
Nah, we didn't need it.
So all we need to do is copy and paste the data then.
Copy and paste.
Okay.
So Ms. Borby, what we're going to do here is we're going to make a function. We're going to use the function that we made, and we're going to get all of the predicted values, just like we did in the last 2 assignments. So here's our function right here, this third line.
Okay.
Okay, pay attention here. This is the hard part. Equals. Sign. Just make everything capital, if I can. Sign. Parentheses. Okay, now this is a little bit weird. Radians. Parentheses. 0.98. Parentheses. X. It's not X. It's this. A2 minus 80. Parentheses. 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 Plus 12.2. That's a lot.
Okay.
Equals. Made a mistake.
To accept the correlation, click yes. To close this.
Actually, I didn't even do it right. I forgot my number in front.
3.5
times.
Let's
put a times. Radians. Maybe put a times right there too. There we go. It's pretty close. You see that? Drag it all the way down. And there you go. Okay. Now what do we need to do? So now we have our Wolfram and we have our predicted. What do we need to do?
We need to find a difference there.
We need to find the difference. So difference for P1. Okay?
Yep.
Equals this minus, minus that. Enter. Drag it down. There. Now
we're going to go in and find our P2s.
Wait, absolute value.
Oh, absolute value.
P1. Okay, how do we do that?
Is there a command for absolute
ABS.
value? ABS.
Right there. Enter. And down. There. And then we can just do right here.
Sum it.
Sum. Capital. Sum. Here. To there. Parentheses. Done. There's your 2.3. You got to do the same thing for the other line, which is the
curve.
The curve for the computer's model. Compare it to the one you just made. Good luck. I'm not going to go through all that. I think it's the exact same process twice.
Thanks.
Anything else, Miss Barbie?
Nope, looks good.
You love diamonds?
I love diamonds. I love Excel.